All right, in Chapter 2, Section 3, we are going to learn about rate of change and slope. So rate of change and slope are the same thing. However, slope deals with lines, and rate of change is the same thing as slope, but it's when it's not a line. So we use slope when we have a straight line. Rate of change we need to use when it's not a line. But they are the same thing. So our rate of change formula we have as the change in y over the change in x. So this is the formula for rate of change. In terms of x and y, we would say it is y2 minus y1 over x2 minus x1. And then sometimes it's referred to as the change in y over the change in x. So this little triangle is the same thing as saying the change of. So in our first example, we need to refer to the graph, find the average rate of change of the percent of total music sales for both CDs and downloads from 2001 to 2008 and compare the rates. So first thing, we're just going to look at CDs. So CDs is the blue line on top. Our rate of change formula is the change of y. So y2 minus y1 over x2 minus x1. The change of y's over the change of x's. So from 2001 to 2008, we are going from this point here to this point here. So we could say that this point, looking at our x-axis, this is 2001. And at 2001, our CD sales is 89.2. So this would be our coordinate point for this first point. And then the second point, we have 2008. And our percent at 2008 is 77.8. So this first point is our x1. The second one is our y1. And then our second point, we have our x2 and our y2. So now we plug everything into our rate of change formula. So we have our y2, which is 77.8, minus the y1, which is 89.2. And then that is over x2, which is 2008 minus 2001. So 77.8 minus 89.2. Would be negative 11.4. And 2008 minus 2001 would be 7. So if we divide negative 11.4 by 7, we get negative 1.628. We could round it to 1.63. So this is our rate of change for CDs. Next, we're going to look at the red line. So the red line is our downloads. So our first point at 2001 is 0.2. So we go from 0. Well, this is 2001. So 2001 is our x. And then 0.2 is our y. And then our second point is 2008 and 12.8. So this is our x1, y1, x2, y2. So we plug everything into our formula now. Our y2 is 12.8, minus our y1, which is 0.2, over our x2, 2008, minus 2001. 12.8 minus 0.2 is 12.6. And 2008 minus 2001 is 7. So 12.6 divided by 7 is 1.8. So our rate of change for downloads is 1.8. So when comparing these two rate of changes, rate of change we said is the same thing as slope. So if we have a negative rate of change, that means we have a negative slope. So our CDs is decreasing because it's negative. So the rate of change is decreasing for CDs, and then our rate of change is increasing for downloads because it's positive. So anytime you have a negative rate of change or slope, that means that your line is decreasing. So first it asked us to find the CDs, then we had to find the downloads. So this was like 2 problems in one. The next one is just, so it says the table shows the temperature of a solution after it has been removed from a heat source. Find the rate of change in temperature for the solution. So if we start at 0 minutes, this is our starting point, and we're going to 12 minutes, so this is our ending point. So we have our time is going to be x, so this is x1, temperature is y, so this is our y1, 12 would be our x2, and 118.4 would be our y2.
Miss Carver?
Yes.
Alma Dean wanted me to tell you that she's having technical issues, so she's trying to get in.
Yeah, she just got in. Thanks for letting me know. We plug everything into our formula, which is y2 minus y1 over x2 minus x1. So our y2 is 118.4. Our y1 is 143.6. And then our x2 is 12, and our x1 is 0. So all I did was plug everything in. Now we need to subtract the numerator and then subtract the denominator and divide the two. So on the numerator we have 118.4 minus 143.6. And we get negative 25.2. On the bottom, we have 12 minus 0, which is just 12. Now we divide, so we have negative 25.2 divided by 12. And this gives us negative 2.1. So our rate of change is negative 2.1, so we're decreasing here. If we needed to put a unit to say like what this negative 2.1 represents, what unit do you think we would put here? So we are talking about degrees, but we're talking about degrees over a certain amount of time. So we would say our degrees would be Celsius. So to be more specific, we could say degrees Celsius. Per minute. So we are decreasing, because it's negative, 2.1 degrees Celsius per minute. An easy way to think about it when trying to determine what your unit would be, on top here we have degrees Celsius. On bottom we have time, which is minutes. So it would be Celsius per minute. So degrees Celsius per minute. So you just have to think what's on top and what's on the bottom. All right, let's go to our next example. So our formula for slope is the same thing as our rate of change. So we have our y2 minus y1 over our x2 minus x1. So our x1 and y1 come from the same point, and our x2 and y2 come from our second point. So the slope of a line is the ratio of the change in the y-coordinates to the corresponding change in the x-coordinates. Same thing we were doing before, a change in y over the change in x. The slope of a line is the same as its rate of change. So here we need to find the slope of the line. It asks us, what rate is the pool being filled? When we see rate, we know we have to find the slope. So our first point here, we're going to call 3 our x1. 108 is going to be our y1. 7 is our x2 because this is our second point, and 252 is our y2. And now we plug everything into our formula. So our formula is y2 minus y1 over x2 minus x1. So our y2 is 252. Our y1 is 108. And then on the bottom, we have our x2, which is 7, minus our x1, which is 3. So 252 minus 108 is 144. And then 7 minus 3 is 4. So now we have 144 divided by 4, which is 36. What do you think our unit would be here? 36, what are we talking about?
Gallons per minute.
Awesome. So on top, sorry, you're just a bit too slow. On top, we are talking about our gallons. On the bottom, we're talking about minutes. So we have gallons per minute. So our answer would be 36 gallons per minute. That's an awesome question. So it doesn't matter which one we call our first point. If we wanted to call this x2 and y2 and this one be our x1 and y1, it doesn't matter as long as like these are both the 2's and these are both the 1's, it wouldn't matter. So you just have to keep it like consistent, like one point is going to be your first, the other point's your second, but it doesn't matter which one's your first and which one's your second. All right, our next example, it says find the slope of the line that passes through -4, 3, and 2, 5. So what would our x1 be?
-4 and 2.
So our x1 is -4, and our, what's our x2?
2.
Perfect, this is our x2. What's our y1?
3. 5.
And then what's our y2?
5.
5. So now we plug everything into our formula. So we have y2 minus y1 over x2 minus x1. So our y2 is 5 minus our y1, which is 3. Our x2 is 2 minus our x1, which is -4. So on top we have 5 minus 3, which is 2. And on the bottom we have 2 minus -4. What do we get when we have 2 minus -4?
6.
6. This becomes a big plus sign, so it's just 2 plus 4, which is 6. Can we simplify 2 over 6?
Yeah, 1 over 3.
1 over 3. So 2 goes into both of these, so we can divide the top by 2, divide the bottom by 2. And we get 1 over 3. So our slope here is 1 over 3. Any questions on this one? So when you find the slope, you're always going to see that your points line up. So our point here is 2, 5. The 2 and the 5 are going to be right on top of each other. Our next point is -4, 3. So the 3 and 4 are going to be right on top of each other. So your points always have to line up. That's because your y2 and x2 line up and your y1 and x1 line up. So you just always have to make sure that if they're in the same point, they go on top of each other. All right, our last example says find the slope of a line. So here it doesn't give us any points, it just gives us the line, but we can use this line and just name 2 points on the line. So I'm going to use this point up here as our point number 1, just because I want the line to go through, like I want to know exactly what coordinate it is, and this line goes through like lines. It's not in between any, so we can tell what point this is. So what would the coordinate of this pink point be?
8 and 4.
8, 4, perfect. And then I'm going to use this point down here as our second point. So what would the coordinate of this green point be?
-8 and
-8, -2. Perfect. So I'm going to call the pink point our first point. So I have x1, y1, and the green point is our x2 and y2. So I'm going to plug them all into our formula. We have y2 minus y1 over x2 minus x1. What is -2 minus 4? -2 minus 4. -6. And what is -8 minus 8?
-16.
-16. Perfect. So can I simplify this -6 over -16? We can divide the top and the bottom by 2. So what do we get when we divide both by 2?
-3 over 8.
So we get -3 over -8, but when we have a negative over a negative, it becomes positive, so 3 over 8 is our answer. Would I get the same answer if I picked, let's say, this point here, which is 0, 1? What do you think? So if this is my new x1 and my new y1.
Yeah.
Yeah, let's try it. So we start with our y2 minus y1 over x2 minus x1. -2 minus 1 is -3. -8 minus 0 is -8. A negative divided by a negative would be a positive, so we have positive 3 over 8. So we would get the same answer no matter what points we picked on our line. We just have to make sure that they are on our line.